Hello, I'm Mr. Howard, and in this video we are going to look at combining like terms. This video is targeted for Algebra 1 students, but combining like terms is a very important skill because you will use it in Algebra 1, you will use it in the algebra portions of geometry, in Algebra 2, and pre-calculus, and then calculus, and then of course college level classes like college algebra, trigonometry, and college level calculus. So being able to combine like terms is a very important skill because you will continue to do that as you advance in your math classes. Alright, so let's take a look at some vocabulary first, and then we will look at 6 different examples of combining like terms. So let's start out with the vocabulary here. So the first vocabulary word is an expression, and we've seen that word before. It's defined as any mathematical calculation or formula combining numbers and or variables. Expressions may not contain an equal sign or any type of inequality sign. If you take an expression and you put an equal sign into it, it then becomes an equation. So, or if you put in an inequality sign, it then becomes an inequality. So that's why that part, that second sentence is in there to make sure that you understand. So let's look at some expressions. X plus 5 is an expression. 5 plus 2 is an expression. X squared plus 3x plus 2 is an expression. Okay, all of these are examples of expressions. Again, if you ever add an equal sign or an inequality sign, it then goes and the whole thing becomes either an equation or an inequality. Okay, so make sure that you understand that part. So let's look at the next vocabulary word. An equation, a mathematical sentence built from expressions using one or more equal signs. So if we take, for example, this expression, x plus 5, we add an equal sign and we put another expression, so say this expression, on the other side of the equal sign, we now have an equation. So this component right here, this is an expression, this is an expression. Once we set them equal to one another, they together become an equation. Okay? All right, a variable. Next vocabulary word. A variable is a quantity that can change or that may take on different values. A variable also refers to a letter or symbol representing an unknown quantity. So that second sentence is probably the most common way that you can think about it. All right, but it's important to understand that that variable, that letter, that symbol represents a quantity that can change or that may take on different values, and that's exactly what a variable is. So in the case of x plus 5, we'll just keep using that. Our variable is x. Okay? In this expression, x plus 5, the variable is x. All right, next word, term. Term. Parts of an expression separated by addition or subtraction signs are terms. So let's use we'll just keep using this, x plus 5. X plus 5, in this case, x is a term, and 5 is a term. Okay? So we have two terms in this expression. They are separated. Notice they are separated by this addition sign. Okay, that's the key. I think the easiest way to remember what a term is a term. Each term is separated by a plus or a minus sign. Okay? I should say subtraction sign. Plus or subtraction sign. Okay? All right, next, a constant. A constant is a term or expression with no variables. Okay, a term or expression with no variables. So if we write x plus 5, x is a variable and 5 is a constant. So the constant is 5 in this case, and the variable is x. All right? So the way that this is written, I think it's important to understand that it can also be an expression with no variables. So if we write 5 plus 2, that is a constant, okay, because it's an expression without any variables. So this up here would be also an example of a constant. All right, the next vocabulary word is coefficient. The number multiplied times a product of variables in a term. All right, so let's write out an expression and identify some coefficients. So we'll make up, well, let's use the one that we had up here. We'll just use this one right up here. So let's write that. X squared plus 3x plus 2. Okay, so let's kind of go through this. Our other vocabulary words along the way. So we have 3 terms here. One term, second term, third term, because they're separated. Each term is separated by, in this case, an addition sign. So we have 3 total terms. So coefficients, that is the number multiplied times a product of variables in a term. So it's basically the number in front of a variable term. So this x squared has an implied 1 in front of it. So the 1 would be the coefficient of this x squared term. This x term has a 3 in front of it, so the coefficient in this case would be 3. So we have a coefficient of 1 here, an implied 1. We don't have to write it, it's implied. And then we have a coefficient of 3 in front of this 3x here. Okay? Next, we have like terms. Like terms. Terms which have the same variable and exponent. Make sure we understand that. Variable and exponent. Like terms can be combined using addition and subtraction. On the other hand, terms that are not like cannot be combined using addition or subtraction. Okay, I'm going to scroll this down so that we have we can see this better. So like terms here. Terms that are not like cannot be combined using addition or subtraction. Alright, so let's write an expression here. So let's make one up. 2x plus 3 plus 5x minus 1. Alright, so like terms in this case, let's identify like terms. Terms which have the same variable and exponent. Okay, so we have 2x, that's a like term. And we have 5x, that's a like term. The other like terms here would be 3 and 1. They are both constants. And notice they do not have a variable and they do not have an exponent. So therefore we can combine those. So we have a 2x plus 5x. That, when we simplify that, that would give us 7x. And then we have positive 3 minus 1 would give us a plus 2. Okay, so we've just simplified this expression. Okay, like terms were 2x and 5x because they had the same variable with the same exponent. The 3 and the negative 1 go together because they do not have a variable and no exponent. So therefore they still qualify as a like term. Alright, the next word, simplify, which is what we just did here. To use the rules of arithmetic and algebra to rewrite an expression as simple as possible. So see this example right here for an example of simplifying. We will, when I talked about we're going to use combining like terms throughout your math career, well, we will also be simplifying because when we gather like terms, that helps us simplify. Okay, notice how 2x plus 3 plus 5x minus 1 is more complicated than 7x plus 2. So 7x plus 2 is simplified compared to this. That's where this word comes from. Alright, last but not least is combine, or you might also hear it as gather like terms, and that is to simplify an expression by combining all like terms into one term. So we did that here. Okay, so we combined the like terms of 5x and 2x, that made 7x. That was combining like terms. Then we combined 3 and negative 1 to give us 2. We combined those like terms, and that act was simplifying. Alright, let's look at some examples here. All right, example 1. Identify the number of terms, the like terms, the coefficients, the constants, and variables for each expression, and then simplify. Okay, so let's do all of that first. So the number of terms, how many terms? We have 1, 2, 3, 4. Notice each term is separated by an addition or subtraction sign. Okay, so we have, write that over here, 4 terms. Okay. Like terms, which ones are like terms? Well, we have 1 and 1 are like terms. Now that's off the screen there. Let me redo that. I'm going to put LT, okay, for like terms. 1 and 1 and negative 13x and negative 14x are like terms there. Coefficients. Okay, coefficients, we'll just underline those. 13 is a coefficient and negative 14 is a coefficient. I should call this is actually a negative 13, right? Negative 13, negative 14. Those are coefficients. All right, constants. Constants in this case would be 1 and 1. So how about this to make this easy? We'll underline coefficients in blue and we will underline constants in orange there. Okay, identify the variables. The variable here, we've got an x. That's the only variable. We have a variable here. We have a variable here. So we'll make that variables. We'll just draw a green arrow to them. Okay. Now we need to simplify. All right. So let's gather up our like terms. So we can start with the constants. That's fine. We have 1 plus 1. That gives us 2. All right. So we've got a 2 here. And then we have negative 13x minus 14x. So that would be a negative 27x. Okay, and just to get used to writing it correctly as we move on throughout the year, you would normally write these in decreasing order. So your largest exponent variable would go first. So in this case, that would be the x term. So we can write this as negative 27x plus 2. Realize that both of these are equivalent. So really either answer is correct. So I'm going to circle both of these. All right, next. We have 12b minus 6 minus 3 minus 5b. So coefficients, well, we need to identify terms. 4 terms, 1, 2, 3, 4. Like terms, we have 12b and 5b are like terms, and negative 6, negative 3 are like terms. Let me say that again. 12b and negative 5b. I need to include that sign. And negative 6 and negative 3. Okay, those are the like terms. Next, coefficients. We will underline those in blue. So let's get blue selected here, and there's a coefficient. 12 is the coefficient in front of this term, and negative 5 is the coefficient in front of this term. Okay, constants, we underline those in orange. That'd be a negative 6 and a negative 3 right there. Okay, in our variables, we draw a green arrow to those. So b is our only variable, and there's a variable, and there's a variable. All right, now we need to simplify. So let's gather our like terms. So we have 12b minus 5b. Okay, so 12b minus 5b is going to be 7b. So 7b. Then we have constants. We have negative 6 minus 3. That gives us a negative 9. So 7b minus 9 would be our final answer there. All right, number 3, moving on. Terms, 1, 2, 3. 3 total terms. I'm going to label those above. 1, 2, 3. Okay? 3 total terms. Like terms, we have the 7v and the negative 2v. Those are like terms. And negative 11 is the only constant. Okay, now coefficients. We're going to underline those in blue. Coefficients, 7 and negative 2. Constants, negative 11. Right there. variables will just be v. V is the only variable. So right there and right there. All right, now let's combine like terms. So we'll start with the v terms, the like terms. 7v minus 2v is 5v. And then we have the minus 11. So our final answer, 5v minus 11. That is now simplified. Okay, moving on, number 4. Terms, 1, 2, 3. Like terms, we have 2 constants and we have 1 x term. Okay. Coefficients, underlined in blue, we just have 1 term with a coefficient, and that is 6, positive 6. Constants, we have 12 and negative 13. 12, negative 13. Variables, our variable is x, and there's only 1 term with a variable. Okay, let's combine like terms. So x terms, we just have 1 x term, and that is 6x. Constants, we'll combine those. 12 minus 13 is a negative 1. So 6x minus 1. We could also write this as negative 1 plus 6x. Either way is fine. These are both correct. All right, last 2 examples and this video will be done and you will be an expert at combining like terms. So this one is a little more complicated because we've got more terms involved and we've got some exponents, terms with exponents in them. Going to see, yeah, we're not going to have room. So let's just remember that we're underlining coefficients with blue, constants with orange, and drawing green arrows to our variables. All right, so let's look at terms first. 1, 2, 3, 4, 5, 6 terms. So I'm going to write that 1, 2, 3, 4, 5, 6 terms. That almost looks like a 9. Let's fix that. Okay, the next thing that we were asked to do is talk about like terms. So like terms would be 5 and negative 2. Those are like. 2x and negative x. Those are like terms. And 3x squared and 7x squared are like terms. So since this is a little more complicated, let's apply a strategy where we write them where the like terms are together. So let's start with the x squared terms. Okay, so that would be 3x squared, we're just rewriting it, plus 7x squared. That way we have like terms together. And then our x terms, we have a plus 2x and a minus x, a negative x. And then constants, we have 5 minus 2. So plus 5 minus 2. Now we can see we have rearranged this. We have not changed it in any way. We just rearranged it so that now we have like terms together. So it's a little easier to simplify. So we also need to identify coefficients, constants, and variables. So let's do that next. So first thing, coefficients. Let's identify coefficients. So we have a 3 here. The 3 is the coefficient of this 3x squared term. 7 is the coefficient of the 7x squared term. 2 is the coefficient of the 2x term, and technically a negative 1 is the coefficient of this negative x term. There's an implied negative 1 in front of that x. We don't have to write the negative 1 because the 1 is implied there. Okay. Next, let's identify and underline our constants. So we have a plus 5 and a negative 2. And then let's draw green arrows to our variables. So we have an x there, 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 and there. Those are all variables. Okay. All right, now let's combine. So we have 3x squared plus 7x squared. That's 10x squared. Then we have a plus 2x minus an x. So that is a just plus x plus 1x. There's an implied 1 in front of that. Plus 5 minus 2 is a plus 3. Okay, so you can kind of see how rearranging these and rewriting it so that the like terms are together makes it a little easier to simplify, and that's perfectly okay to do. All right, next, and the final problem here. We have 5n squared plus 3n minus 5 plus 2n squared minus 3n plus 2. So we have how many terms? We have 1, 2, 3, 4, 5, 6 terms there. So 6 total terms. Each term, remember, is separated by an addition or subtraction sign. All right, let's go ahead and rewrite this one as well. So we're going to combine, write the like terms together. So n squared, that's the largest exponent, is 2, an exponent of 2. So let's write those together. So we have 5n squared plus 2n squared. Okay, next, our n terms, we have a plus 3n right here. We have a negative or minus 3n there. And then constants, we have a negative 5 and then a plus 2 there. All right. Okay, next let's identify our coefficients. We were asked to do that. So we have a 5 as a coefficient there, a 2 as a coefficient in front of that n squared term. We have a 3 as a coefficient in front of that n term, and a negative 3 as the coefficient in front of that n term. Okay, and then finally our constants, negative 5 and 2. All right, and now variables. So we have a n, the only variable used in this expression is n. Okay, now let's finish this and combine our like terms. So since we have rewritten it where like terms are right beside one another, it makes it a little easier. So that's going to be 7n squared. Now look what's happening right here. Right here. Let's take a look at that. We have a 3n minus 3n. Well, what does that leave us with? That leaves us with nothing. You have 3 of something minus 3 of that same thing, you are left with nothing. So those cancel each other out. All right, so then we just have the negative 5 plus 2, and negative 5 plus 2 is negative 3. So we have 7n squared minus 3. I'm going to do that in green so we don't get confused. 7n squared minus 3. Notice our n terms canceled out, because we could write 0n there, but that's still just 0, so we just leave it off. So final answer, 7n squared minus 3. Let's circle these up. Alright, so after you practice this on your own, you will be an expert at combining like terms. See you in the next video.